Mic on mute if you are not speaking. You will see a function that allows you to raise your hand if you have a question to pose or if you would like to share any ideas or engage in the dialogue. We do request that you kindly wait for the facilitator to acknowledge your hand before you unmute your mic and proceed to speak. Kindly note that all presentations will be made available post this morning session. In order to post any questions on the Q&A, you will find the Q&A icon at the bottom of your screen. If you click on this icon, you will then be able to post questions through the Q&A chat box. In order to join in the chat icon is also found at the bottom of your screen, and you'll also be able to monitor what is going on in the chat using the panel that appears on the right-hand side of your screen. This is the program that we'll be taking you through today. I will just keep it up for a few seconds just to give everyone a chance to have a look at what lies ahead. Thank you, colleagues. Please do enjoy the session. I now hand over to Mr. Brilliant Pleasure to formally start today's proceedings.
Thank you very much, Zama. Good morning, colleagues and partners and stakeholders. Welcome to the dialogue of the Advisory Panel on Climate and Water. And today we look forward to talk to the climate, our summer climate, which we are expecting, and the implications to our daily activities and water, particularly to the water sector and other activities linked to the water. We'll start with our CEO. Let me give him this opportunity to give us opening remarks and officially welcome us to today's event.
Thank you, Brilliant. Thank you very much indeed. And good morning, colleagues. I hope you can hear me. Yes? Thank you.
Yes.
Thank you very much indeed. I'm actually talking to you from an unusual setting today. I know it looks very gray in the background. That's because I had to come and do some transactions in a bank branch, which is not very often that one does that. And the stuff took too long, so I asked them for a space to actually do a webinar. And thanks to the COVID, there are so few clients around. They've actually lent me a little space. It's wonderful to have all of you here. And let me offer the following to kick off where we're going. Firstly, to say that I think what we have launched and achieved to date has been quite phenomenal. The idea around having a consolidated and synergistic view on weather and in part climate forecasting is already having an impact, I think, in a very positive way. And on the back of the products that you've been producing, we've actually been packaging for the Minister of Water and Sanitation ministerial briefs to advise on where we think the weather is going. And the issue about the unpredictability of weather is an age-old cliche, actually. And it's only accurate because our science is not supported to the degree that it should be. Because when it is, then we'll have higher levels of certainty. And with those higher levels of certainty, we will have much more predictability inside the system. We're also having a chat at a very interesting time. I mean, today we're seeing what has become a fierce race in the US around the presidential election. And it's important to mention the US because it seems possible, maybe even likely, that it will return the current president to the White House, where the challenge for science continues. The hard evidence cannot be challenged, but what can be challenged, as you well know, is the funding and the availability and the support to the science infrastructure, because science often tells the inconvenient truth, and the inconvenient truth with regards to many, many things, including the stats associated with COVID. But colleagues, let me deviate from that a little bit and just remind us of a couple of things that are happening in the environment and around why what we're doing is so incredibly significant. The first is that if you looked at the WEF, the World Economic Forum's Global Risk Register, which comes out in January each year, I imagine there'll be a big shift in the new one in 2021. But what we have in 2020 is that for the last 10 years running, there's been an environmental quartet that has been at the top end of that global risk register. It is associated with climate change and our inadequate response to climate change. Natural disasters are very close to the top of the list, and almost on a weekly basis now, we are seeing natural disasters of extreme proportions in some or other place in the world, as we have this week already. And then in addition to that is the issue of biodiversity loss, and biodiversity loss is happening at an alarming rate in the world. It's not a problem only in its own right around the loss of biodiversity, but also what this is as an indicator of the general integrity and health of the environment. And the fourth horse in that quartet, if you like, is the notion of water crisis, which continues to be in the top 5 of global risks in that risk register for all of these years running, and unlikely to change even in next year's register when COVID will dominate, no doubt. Now, we have seen what the impact of that is on the economy, globally and locally. So if we look at South Africa, we have, although we've declared our contraction only recently, the 5 continuous years of drought that we've had on the back of what was termed and verified as the most impactful El Nino event in the last at least 20 years. Some are speculating much longer than that. The mark that it has left on the South African economy has been extreme. And what we are seeing is an accumulation of that effect over time. And with the measures that have already been declared, we've had 3 consecutive quarters of contraction, and 2 quarters alone put us into recession. And now that has gone into the 3rd quarter, and the 3rd quarter was pre-COVID. We are quite confident that the COVID quarters will also represent contraction. And in fact, the Minister of Finance talked about this in the medium-term budget policy statement. He talked about the South African forecast being downgraded even further from a contraction of 7.2% to now a contraction of 7.8% for the 2020-21 financial year. This is quite extreme. It then went on further to say that the recovery from this will be at 3.3% in the next financial year, and that growth drops down to a 1.5% average over the 2 years after that, maybe going up to a 2%. But what that actually means in real terms is, as bad as things were in January 2020, and they were, and we know this, the Minister of Finance is saying that it's going to take us 5 years to get back to the bad position that we were in January 2020. This is hectic, because it's not even saying how much longer it will take to get us to the point before the recession began and to the point of a higher growth rate before that. And the accumulated effects express themselves in various different ways. I mean, for the first time in the history of this democracy, because in the apartheid government we did have these phenomena, but in the history of this democracy, for the first time we're talking about the possibility of the debt to GDP ratio approaching 100%. It's incredible. So colleagues, in the light of all of this, there is another factor that comes into this play, and that's the factor of COVID. Now, let me talk about the economy first. The first thing about the economy is that an ability view of weather and climate, sorry, absolutely about 2020 year, which is excellent. But we know that this is an up and down movement. We also know that the overall economic recovery depends very intimately on many factors, the primary factor being COVID, of course, because COVID continuance means lockdown continuance, means an inability for people to get back into the productive stream around the primary production sectors. You know, the work that we do can go on because we have the instruments of 4IR and our ability to work virtually. But if we're looking at the primary production sectors around mining, around agriculture, around primary industry, and to a very large extent, secondary manufacturing and tertiary manufacturing, it cannot happen until we get out of this lockdown. So the lockdown, of course, depends on the direction in which the pandemic moves. And one of the phenomena that is becoming more and more apparent all over the world is the connection between weather, in particular the severity of winters, and how the COVID responds to it. So while we organize ourselves to primarily produce these predictions and these forecasts around very primary planning, a new client in this regime for us is, of course, the people managing this COVID epidemic in this country and in this region. Because extreme weather in either direction, either a very hot summer, a hot, wet summer, or a cold winter, or both, will clearly have very negative implications for how this pandemic pans out. And this is something that we have to pay very close attention to. Further, we have to engage ourselves in a way that organizes to advise the decision makers and the planners in a much more robust scenario than we've been able to do as a collective community of practice for the longest time. Now, part of the reason is, of course, that we didn't have the consolidated data available, and we're getting that into a much better shape. Another part of the reason is that we are desperately in need of major scientific investments in this domain, including some serious hardware like supercomputing capacity to become much more accurate around what we're doing. It is also true that we need a strong reinvestment. And then, even then, it wasn't so good before. A much further investment around our ability to engage ground truth in a much more meaningful way. I mean, we need weather stations everywhere, immediately. And then an ability to consolidate that data in real time and crunch it in a way that organizes for us to have a much better prediction ability on the one hand, but on the other hand, have it organized in an accessible way that every decision maker at every point in the system has an ability to have enhanced decision making because the data is available in a way that they can use it. Now, this is a big idea. It's an idea that the WRC has been talking about for quite a while. We've been putting it under the banner of the Observatory Project. And one of the mainstays of the broader Water Observatory Project is, of course, weather and climate. There are many other things, naturally, and folk are quite aware, I hope, that we think we got a leg up on our water quality monitoring abilities with the introduction of the wastewater surveillance program. And if the wastewater surveillance program works well, if it gets the right kind of investment from government and other players around this, this will in turn become a very important building block around the water quality side of the observatory. And that, together with the weather and climate side and several other components, may eventually elevate us to the place that we want to see around having a very robust system for the country that has observatory capability around water matters, around agriculture matters, and working together with the envisaged National Institute for Public Health around the health parameters, and that enables us to be in a much better place and use much more meaningfully the data we should be collecting everywhere around us. Then The other point that we need to examine in some detail with reasonable robustness is this issue around the global acceleration framework for SDG 6. The first point I'd like to make is that this acceleration framework, which was declared earlier this year by the UN Secretary General, along with the Decade of Action 2020 to 2030, is of course specifically designed for water and sanitation targets in SDG 6 to come close to being met by 2030, because currently we're pretty far away from those targets. But in a way that organizes for this effort to be complementary to the efforts around all of the other SDGs, and using in particular the SDG around partnership to be able to have a meaningful nexus type approach so that we are able to achieve water in a manner that enables us to get closer to the energy targets, to get closer to the food security targets, to get closer to the targets associated with a better climate scenario, to the targets closer associated with the ending of poverty. So the way we handle this and the way we plan for this depends very, very strongly on our ability to be able to read the patterns of weather, to read the movements in climate much more accurately than we currently do. We want to organize for this to be inculcated into the decision-making frame in that kind of powerful way. So colleagues, it is a big task that we've signed up for. And maybe the task has become a lot bigger when we first got around the table in the WRC building to have these discussions. But there are three things around this that I think we must take heed and we must take heart from. The first is that, in my view, and I know you will share this view, and hopefully soon many other people will share the view, is that this group is starting to present some very good products. And that is a very, very big plus. And this is not just about the consolidation of the different data sets that we have. It is about the actual value add that comes from putting the expertise together in a room. And we've been very successful at that. You know, we always knew we had that kind of capacity. But I think looking at the products that are coming out, I think we're a little bit surprised at how well the complementarity has worked inside this project, because that's not usual. We try this in many, many sectors where you bring the experts in the room and you first have to go through a storming phase before you can get to the point of the productivity that you're looking for. And in this particular group of folk, I think this just has eliminated the storming and the norming and those other phases and went straight to performing. And I think that is a huge accolade. The second is that some people that matter are beginning to listen to this. And they are going to listen a lot more closely, a lot more intensely, and there'll be a higher demand for what we're able to do and produce. And naturally, this increases the pressure. This increases the pressure on our ability to be much more accurate around those predictions. And let's be clear that although we produce these very good reports that says this is what is likely to happen, and then we are very explicit around the caveats that say these are the limits of the forecasting, the reality is that most decision makers just look at the forecast and ignore the qualifications. So we are wary of that, and we will know how to wade through that. But the last thing that I think we should take heart from is that I think we are organizing on the back of the high scientific profile that's already coming out of this group. We're organizing some kind of impetus and creating a space to have a very serious discussion with government in particular, but maybe also some private sector partners around the investment in the kind of infrastructure that you need to be able to do this a lot more easily in the longer term. So the work this group is doing, together with some of the motivations that are happening around the Center for High Performance Computing, together with the discussions that we're having with the likes of SANSA, is starting to look like the thing that could be a very reasonable 2021 proposal around creating the kind of capacities that we can all benefit from inside this domain. Now, it's early days. It's difficult days to have discussions around new investment because, as you saw with the medium-term budget policy statement, the angle that the Minister of Finance, and of course, the Minister of Finance speaks on behalf of Cabinet. He doesn't invent this himself, but they've taken an austerity approach to this. I personally am quite against austerity approaches. Austerity approaches help those who are already XXXL, and you have the austerity, you can drop down to XL. But when you have most of the population sitting at XXXS, the little that you take away from them puts them in oblivion. And that's something that we have to engage. But I think that even within this difficult climate of austerity, the sifting out into the cost benefit, if we can produce that argument more accurately, will be heard. We will at least get into the conversation. So colleagues, I wish you very well with today's webinar. I'm looking forward to the expertise that we have around the table, putting their stuff up on the screen, and Shafiq has promised to have a very good consolidation at the end of this as Stanley. And let's see if we can continue the momentum that has already been started, because as I said, it's been good, it's been positive, and it's been highly appreciated. And I think we have a good trajectory that we're going on. So colleagues, with those few words, I think I must stop there. Brilliant. Back to you, sir.
Thank you very much, Desikan, for the kind words of encouragement and also reminding us that the scope is bigger and the impact is even cutting almost all the sectors. Thank you very much. I'll now invite Kopas and the South African Weather Service team to talk to us about the outlook of the current summer.
Thank you, Brilliant. Just want to set up quickly. Can I just get confirmation everyone can see the presentation?
Yes.
Thank you. All right, welcome everyone. So my name is Kobus Olivier. I'm a scientist at the South African Weather Service in the Long Range Forecasting Group, working under Christine Engelbrecht, who's the lead scientist in the Long Range Forecasting Group, and then Mary Jane and Joel, the chief scientists at the South African Weather Service. Just credit to Christine Engelbrecht. She made this particular presentation, which is the overview of the season and a reflection on extreme climate and weather events. So we'll start off with just looking at what happened in the last couple of months. So that's from April in 2020 up till September. And this is mainly looking at what happened in the winter season. So just an indication for those that may know or may not know yet, these maps are actually freely available on our website. If you go to the climate section under historical rainfall maps, you can choose quite a few years back if you're interested in previous rainfall events, specific months, even 10-day maps as well. So in this winter season that's just passed, we can see it was started quite badly. Even June, that was an indication of rainfall. Generally, you want the most of the rainfall in this area is in the western side of, say, the Western Cape province. But in June, July, August, quite good rainfall. But other than that, not a great start to the winter season. But the main midwinter season had at least good rainfall. Looking at some temperature conditions in winter, The top row is from May to August this year, maximum temperatures. The bottom row is the minimum temperatures, also from May to August. And what you can see is cooler than normal early mornings occurred over large parts of the country. And the month of August was colder than normal over large parts of the country, minimum as well as maximum temperatures. So you can see a distinct difference between the maximum and the minimum temperatures, mostly due to the variability of the cold fronts coming over the country. It's not an as regular occurrence, and it mostly affects the minimum temperatures. You can see the maximum temperatures being a little bit more constant than minimum temperatures. And just to move on, if we look at the previous summer season, so obviously when we look at the forecast for this season is now going to be 4 summers. So just to have a look at what we are coming from a summer season point of view, looking at the previous summer season. So on the left-hand side, you'll see the October, November, December 2019. So basically the start of summer, and we'll have on the right-hand side is the January, February, March, the end of summer. This is January, February, March this year. So that's the full 6 months typical summer period. And from top to bottom, we're looking at the rainfall deficits, so percentage of normal. And then we look at the anomalies of maximum temperatures and anomalies of minimum temperatures. And what we can see here is that the season started off quite badly, with the exception of some areas in maybe Northwest and Limpopo, but then gradually increased or improved as we went to the end of the summer season with regards to rainfall. With regards to temperatures, you can see some of the effects of the rainfall in the temperatures later in summer, where cooler temperatures started to occur as more rainfall events, more cloud cover occurred during end of the season. And again, we're talking about the last summer season, 2019-2020. Now, as we move on to the forecast for the next summer season, one of the very big things that we look at to give us an indication what might happen for the summer season is the El Nino Southern Oscillation phenomena, which is a phenomena or an event, teleconnection between the atmosphere and the ocean, a very large area over the Pacific. Generally, this is sea surface temperatures that increase or decrease depending on which phase it goes through for La Nina or El Nino. La Nina is a decrease in temperatures over large parts of the Pacific Ocean, generally from the western side of South America extending into the equatorial Pacific Ocean. And El Nino is warming of those temperatures. So those two phases occur in some situations up to about 2 years, that they can exist and impact various places in the globe. For South Africa specifically, generally we'll see an interesting graph later on where we look at this is not a one-to-one relationship of when you have a particular La Nina. For South Africa, that usually means favorable rainfall when you have a La Nina state, and during summer, I have to say these are specifically when it goes over summer. In winter, we don't really see an impact, or it's at least a very more complex impact on winter seasons for South Africa. But for summer, which is what we're looking specifically now, when a La Nina event occurs, we expect favorable rainfall, above normal rainfall conditions. And during El Ninos, I think we all heard in the past, one of the big effects when we get dry conditions. And as I said, because these events can last for up to about 2 years, can cause droughts with consecutive dry seasons occurring. And important to note, on a bottom left corner, you can see these typical indications that we look at. In the next slide, we'll look at one of these zones. The typical zone we look at specifically for South Africa and many other places in the world, really, we look at the Nino 3.4 region. So in the left, bottom left corner, you can see the graph there showing the Nino 4 region, the Nino 3 region, and the Nino 1+2 regions. But we have there's a very specific region that's a very good indicator of what might occur, and that's the Nino 3.4 region. So a lot of the graphs that you'll see in this presentation and even in websites around the world will look at the indication of the sea surface temperatures in the Nino 3.4 region. And something to note, a study was done by Landman and Baraki about multimodal forecast skill, and they looked at specifically forecast skill during La Ninas and El Ninos and neutral years. And it was found that during these specific phases, the skill increases. So the confidence in the forecast, in the seasonal forecast during summer, increases when there is a La Nina or El Nino in effect. When it's neutral, the skill unfortunately drops off. And this is very typical what you will find when there is a neutral state, so not either of the El Nino or La Nina, that we will indicate uncertainty to what is going to happen over South Africa. And generally when there's either one of these events ongoing in summer, there will be a lot more confidence, as we will have specifically in this particular forecast as well. So then moving on, what is the current state of the El Nino Southern Oscillation? So here we see on the left-hand side, that's the top left, that's our own local seasonal global forecast model that is also, it's coupled to an ocean model, so we are able to give forecasts for the sea surface temperatures as well, indicating a prediction of quite a strong La Nina during the November, December, January period, even extending into the later summer months. And on just next to that, on the right-hand side, this is multiple dynamical models being pulled by the IRI, the International Research Institute. So they pull all these global models and look at a wider range of model forecasts ensemble. And you can see that generally most models are agreeing that there would be at least a moderate to strong La Nina occurring during our mid and late summer. At the bottom is just another one. There's actually quite a lot of indices, but they are pretty much based on the same premise. The Oceanic Nino Index also just gives you a history, and you can use this to give you an indication of when there was strong and weak La Ninas and El Ninos. All right, so then we go on to the forecast. This is the forecast by, I think at this stage, 3 or 4 multimodal forecast done by the Weather Service. This is what you will see in our Seasonal Climate Watch, to be released, I think, probably end of this week, hopefully. So this is indication of rainfall. So in green, you'll see where the chances of above normal is higher than the chances of below normal. And the brown is where it shows the chances of below normal rainfall is higher than chances of above normal rainfall. So just to explain this a little bit, how that this can be. So in seasonal forecasts, you generally don't have a deterministic forecast of it's definitely going to be above or it's definitely going to be below. We have a range of forecasts saying there's a percentage chance of below normal, percentage chance of near normal, and the percentage chance of above normal. And then we look at those percentages, obviously they come up to 100%. And then we'll have a look at see what the distribution of those is. So we can then use those to give us an indication of where it's more likely to be either above normal rainfall or below normal rainfall. So this is what this graph tries to do, is to put it on one map, what the chances are, what the higher chances are of the events that could occur. So this gives you from left to right the November, December, January, February, which is midsummer, and January, February, March, for next year. So all in all, mostly above normal. A bit of concern definitely for the eastern parts. This is actually something that's come up in SARCA forecast as well. Eastern parts giving an indication of likely drier conditions. So I think we will also see in the next couple of slides that this particular region that is indicating to have a possibility or a higher likelihood of dry conditions over the KZN, Northeast Free State, Southern Mpumalanga, but these regions also dry in the previous season. So this is quite a concern. Obviously, if two consecutive dry seasons, we expect significant impact. One other thing that you have to realize with this forecast is that we have specific rainfall regions. So this particular season that we look at here for the early, mid, and late summer, we don't really look too much in anything into the southwest. So those areas don't really receive a lot of rainfall. It's not their rainfall season now. So even though there's a forecast of above normal, it's not expected to be a significant amount of rainfall. So just keep that in mind. When you look at these maps, it's not as if we are now saying that there's going to be a lot of rainfall in the southwestern parts of the country, the Western Cape province, during summer. They can definitely get rainfall at these periods of time, but we don't expect that to be as significant as what we expect in the summer rainfall areas, which is generally the northeastern half of the country. Moving on to temperatures. Interesting, the minimum temperatures is on the top row. So again, you have from left to right, early summer, midsummer, and late summer. And on the bottom, the maximum temperatures. A lot of below normal, especially for the northeastern parts in both the minimum and maximum temperatures, obviously indicating that significant rainfall events and probably a higher frequency of cloud cover to occur, giving you cooler temperatures, both minimum and maximum. Obviously, then for the southwestern parts, it will probably be less so, as I explained, it's not really their rainfall season. So the frequency of rainfall events and cloud cover would be less than what you would have, or less of an impact than what you would have in the northeast. And then just looking at some other forecasts from other centers. So the University of Pretoria produces seasonal forecasts as well. So this is just a seasonal forecast for December, January, February, also indicating above normal rainfall for most of the country, with the exception of the very extreme northeast. And on the right of that forecast, you can see some skill levels. Generally, the red areas show improved or increased skill levels. And you can see that there's the skill levels, the top one, it shows the rock area for the DJF rainfall. This indicates, well, when the forecasting system is producing above normal rainfall, or the higher category is above normal, how reliable is this over a certain period of time? And you can see that it's more reliable over the very northeastern parts over the country, and it's a prediction of above normal. Interestingly, the IRI indicating more favorable rainfall over the central parts, but there's a little indication of over the northern Free State. Obviously, it's a bit difficult to see exactly where this specific is, but indicating below normal rainfall conditions over northeastern parts of the country, giving us a little bit of an uncertainty of in between forecast productions. And then just to the right of that, this is the Copernicus Climate Service, giving a multiple model. I forget exactly how many models. It's about 7 or 8, I think, but I speak under correction. So they also have where multiple models are pooled into one, and the forecast. You can actually see it's 1, 2, 3, 4, 5, 6. You can see on the top of the graph, it actually names all the models that contribute to this multi-model forecast, the ECMWF, Met Office, Meteo France, CMCC, I think is Canadian, maybe. DWG is the German, the US, and Japan Meteorological Association, I think. So multiple models contribute to this. So they're also indicating more favorable in the central parts of the country, rather than it being specifically in the northeast. So some uncertainty in the northeast with the two, we can say, international forecasts. The two more locally produced forecasts more favorable to the proper summer rainfall regions in the northeast. And then there's something interesting, and this comes down to what I was saying when we looked at El Nino Southern Oscillation, where it's not a one-to-one relationship. When you get a La Nina, you will definitely get above normal rainfall. So this is just an indication of some specific years where you had strong La Ninas in the top row, some moderate El Ninos, sort of in the, well, two of them in the mid row, and then some weak La Ninas. So you can see that it's quite variable. So it doesn't mean if you have a strong La Nina, that means they will definitely be above normal rainfall conditions. You can see in 1998, there was significant dry conditions over the central parts of the country. 2007, there was significant dry parts over the extreme northeast and eastern parts of the country. And then you can even see when it's weak. There's in 2016, 2008, 2005, significant higher rainfall anomalies that occurred. However, in 1984, there was also dry conditions in the central part. So this is most definitely, you should never look at the influence of La Nina and El Nino as a definite one-to-one relationship. Also, always keep in mind that it can be quite variable in the rainfall patterns that exist over South Africa. You can, however, see that there is a strong indication of favorable rainfall in most parts of South Africa, especially in the eastern parts during a La Nina season. However, we can't with any confidence say that it's a 100% certainty that all of the summer rainfall regions will receive above normal rainfall, because in reality it can vary quite a bit. All right, so in summary, a La Nina event is present and predicted to continue in our summer season. As we've seen in the graphs, it actually is strengthening. So we are probably looking at a moderate, strong La Nina event. But again, as we just saw in the previous graph, this does not necessarily mean that you should be more or less confident just because of the strength or intensity of a La Nina event. We tend to look at the consistency of the forecast of La Nina and also the spatial degree and its influence on the upper air over the Pacific Ocean. La Nina conditions are usually associated with cooler than normal and wetter than normal conditions over summer rainfall regions of South Africa. This is what we explained, but again, very important to note, this is associated with, and it's not a one-to-one relationship. It's not definite use to forecast the summer. It's just an indicator that will either increase or decrease your confidence of your forecast. So for example, we have an above normal forecast mostly for South Africa or northeastern parts of South Africa. There's also a La Nina in effect, so that increases your confidence. Sorry. The current predictions for summer season are favorable for above normal rainfall over most of the summer rainfall region, but less over the northeastern parts of the country towards the end of summer season. So this is what we saw in the very first, or our official forecast, that most of the country is showing above normal. And again, we're looking specifically more to the northeast parts of the country, which receive the rainfall now. But when you move on to the late summer, there's an indication of below normal conditions, specifically for our forecast to the eastern part of the summer rainfall regions over the northern KwaZulu-Natal, northeast Free State and southern Mpumalanga area. But there's also some indications of, even in the midsummer, from other centers, such as the IRI showing in the northeast indications of dry conditions, the very extreme northeast from the University of Pretoria forecast for dry conditions, and the uncertainty from the Copernicus forecast for the northeastern parts of the country. So all in all, I would say there's a confident forecast for most parts of the summer rainfall region to be above normal. However, there is a risk of some minor areas within the summer rainfall region to experience drier conditions. Now, it's difficult to say exactly which areas. We typically in seasonal forecast, you cannot do that. You usually speak of either most of the region, and some parts might have below normal. Unfortunately, seasonal forecasts are not that accurate to that degree that we can say which areas exactly we expect to be dry and which areas exactly we expect to be wet. But I think we can, with some confidence, say that most parts of the summer rainfall region we expect to be above normal. But there is a risk with some regions in the summer rainfall areas to be drier than normal. And I think that's it. Thank you.
Thank you very much, Kopas. Please remember to post your questions in the chat box. Then we'll respond to them. And then at the end of all presentations, if time allows, then we can take some few more questions from the audience. So now I would like to invite Chris from Department of Human Settlements, Water and Sanitation, to talk to us about the water security implications.
Okay. Good morning, colleagues. I'm not very good in technology. You know me, brilliant. And I would like to ask Tobile maybe to fly up the presentation on my behalf. If I could capitalize on our friendship, please help.
Okay.
Okay, I'm going to load it now. You'll tell me when to move to the next slide.
Okay, will do. You can put it on the presentation mode.
There you go.
Okay, thank you, colleagues. Let's start with the next slide. In this presentation, I'll just go through the projected change in water availability in Africa by 2030, just one slide, and then get to the national water situation under natural conditions, strategic water source areas. And this is just a background, because I think it's very crucial to talk to the background. Rainfall and temperature predictions, you have had my friend Kovas has ably presented on this. So I think I will most probably just jump that slide after showing it up. And then we get to the tools that we use. And again, I'll just stay up there at a strategic level, looking at the National Master Plan and the climate change strategy. And in particular, I'll make reference to the diversification of the water mix. And then we get to the observed trends and changes before we jump into the water situation analysis and implementation of the operating rules and conclusions. Next slide, please. So let's go ahead and look at the projected change in water availability and the national water situation and strategic water source areas. Next slide. This slide it's a little bit old, 8 years ago, but I don't think much has changed. We can just a paintbrush to give you a picture of what the water situation in Africa is projected to be by 2050, and you'll realize that in the Horn of Africa, much of the north of Africa, while there will be projected increase in water availability nearer home here in South Africa, Botswana, Namibia, and Angola, there will be less than 10%. The decrease, there's a projected decrease by 10%. Next slide. Let's stay with me. As you all know, South Africa is one of the driest countries in SADC. And of course, we also know that only 9% of rainfall feeds rivers as runoff, while only 4%, on average, of course, replenishes the groundwater store. And of course, you have heard from Kova's presentation that South Africa is highly variable in terms of climate. And South Africa is, as we know, is currently water stressed. And of course, it's approaching scarcity, depending on how our behavior is going to be, and depending on what actions we take in order to be able to sustain the limited amount of water that we have. Under natural conditions, we have less rainfall. And of course, the evaporation rate is very high, and hence low runoff and low recharge. The key message here is that South Africa is a water poor country, and it is very important to take account of climate change when one considers water management, which means climate change will be superimposed on an already vulnerable water situation in our country. Next slide. Next slide, please. Okay. Now, we also know this map, which was, of course, produced. It's one of the WRC products with the CSRR and other colleagues working on it who produced it. You can see the strategic water sources that we are very limited. It's almost concentrated towards the east and part of the southern part of South Africa. Next slide. And the ground, next slide, please. And the groundwater, of course, is also dispersed there in the Northern Cape up there in the northwest, and in Polokwane area and towards the east, as well as the Table Mountain Group and other rocks, and other aquifers in Southern Cape. Next slide. Now, really, this means that our water, the limited resource that we have, is highly vulnerable because much of it is actually concentrated on less than 10% of the land, which means that it is very important. The key message really is that since these high water yielding areas are vulnerable to pollution, vulnerable to depletion, the monitoring is very, very important, and some other protection is important. And of course, if one thinks of climate change, then one, of course, not only climate change, but also the other non-climatic stress factors, such as land use. It's very, very important for us to use our water sparingly. Next slide. As I said, of course, South African Weather Service has deliberated on this. And of course, we all know that there's expected above normal rainfall in most parts of the country. And of course, you have seen the detailed maps from Kova's presentation. So the main issue here is that in the next 3 to 4 months, though it will rain, the temperature will be high in most of the countries. And then, of course, we need to use water sparingly. This is just a message that I'm trying to share with you, colleagues. Next slide. Now, looking at the tools, next slide. This is just a summary of the National Water and Sanitation Master Plan, which aims to, or with the end in mind, to ensure affordable and reliable access to sufficient and safe water and hygienic sanitation for socioeconomic well-being, with due consideration, of course, to environment, to climate change, things like that. The key objectives are that we need to be very resilient, and the water should be fit for use. And of course, the universal water and sanitation provision, which means that we do not only want to have enough water, but the issue of accessibility is very, very crucial. And of course, equitable sharing and allocation of water resources. And the infrastructure, our infrastructure is falling apart because of lack of good operation and maintenance. This is very crucial. And we all know that in South Africa, mostly when we talk about the challenge of water quality is because of the state of our water, our wastewater treatment works that needs to be looked at as well. And of course, to also not only focus on the supply, but on the demand side as well. So in essence, when we manage our water, it is very crucial that the 6 pointers that are reflected there on the screen, balancing supply and demand, distribution, redistribution for transformation to ensure the equity, managing effective water and sanitation services, which means that our services should also be very effective. And of course, the master plan also demands that we should improve raw water quality and protect and restore the ecological infrastructure. On the other hand, this cannot be done lest the enabling environment, such as the data and management. We all know as scientists that our biggest problem, whatever work we do, is data, data, and data, because that underpins everything that you do. Whether you are doing modeling, you need data. And of course, in South Africa, as we know, like in many other countries, we have a challenge with capacity. So building capacity, not only capacity of individuals, but also the capacity of the institutions. So ensuring research, development, and innovation. And we're very grateful to have Water Research Commission. Not many countries are lucky enough to have this. And we have other research institutions such as the CSIR and the universities. And we need to actually fund and support these institutions if they are really to be able to give us the support that we are envisaging. You can see at the top there where you have an exclamation mark, that without sufficient revenue, either from transfer and tariffs, the water will be unsustainable. And then, of course, the drivers, SDGs, National Development Plan, and all the other legislations, and of course, the issue of climate change over there. So next slide, please. The other tool in tracking climate change is the department's climate change strategy. And this strategy, of course, is aligned to the National Development Plan, is aligned to the National Water and Sanitation Master Plan, is aligned to the National Water Resource Strategy and the SAMAC Regional Climate Policy of SADC, and of course, the white paper on the National Climate Policy. But key to this that I want to share here is that the intent of the strategy is really to guide the effective management of climate change impacts on the country's water and sanitation through appropriate interventions that build and sustain South Africa's social, economic, and environmental resilience and emergency response capacity. It also seeks to promote the application of integrated management as a priority tool to reduce vulnerability, of course, including extreme events, droughts, and floods. So this is not just a piece of paper that we have there in order to tick the box and say we have developed the strategy. It is really guiding the kind of work that we do. So whatever we do now in the department is to implement this strategy. Next slide. From the master plan, I picked on the diversification of the water resource mix. Just to say that this paradigm shift for me is very crucial. There are many, many things in the master plan that are very important, but I picked on this one because in the current water mix, we rely mostly on surface water. You can see currently, according to this cartoon, is 77%, while groundwater is only 9%, return flows 14%, and desalination less than 1% in the big scheme of things. So going forward to 2025, we would like to progressively increase the sources, like for example, to say groundwater should increase from 9 to 10%, while surface water is decreasing from 77% to 70%. That doesn't mean less groundwater. It means just in proportions that we will have to develop more on groundwater. Now, what does this mean? This means this has got, of course, the assumption is that there will have to be resources that would be forthcoming to support Shafiq and the other colleagues who are in the groundwater field to ensure that we realize this dream. And we know that groundwater is being underutilized in South Africa currently, current meaning since 5 years ago, even to current to today, we are almost using only half of what we can potentially use. We know that. And of course, the issue of desalination is also very important to increase from 0.5 to 3%, and acid mine drainage from 0.1 to 1%. And of course, by 2040, we will have to have markedly increased the groundwater as a source. So all these unconventional sources will have to increase. It's not just a talk, it's something that we have to, the test of the pudding will be in all of us working together to ensure that we realize this, putting up resources, and of course, using the skills that we have in the country to be able to realize our dream, in order to ensure that we sustain the limited water that we have. Next slide. Now, let's go to observe trends and changes. Next slide. This slide is showing the current week's average. By current week, we mean last week. I didn't get this week's maps. They're only coming today, so there was no way that I could use them. But last week is not a long time ago, on the 26th of October. So the current week's average compared to the previous year's average. And if you look very carefully, you'll realize that almost in every province, there has been an improvement, with the exception of perhaps KwaZulu-Natal and the Eastern Cape, and of course the Free State. But in most of the provinces, there has been an improvement. And of course, you'll see now, I'm showing these maps not only to show you the water level in the country, the national picture, but also to make sense of why in certain areas we have restrictions, while in other areas we do not have restrictions. So bear this in mind. Next slide. Now, this one, we are comparing the current week's average with the no. It would look like it hasn't shifted, but there are 2 slides there. Yeah, stay with me there. Stay with me there. This is the current weeks compared to last week. Now we are comparing the week of the 26th compared to the week before. And you can see that in most of the countries, there has been a slight decrease in the water levels, except for the Northern Cape, but almost in every province, there has been a slight decrease. Next slide. Next slide, thank you. Now, in terms of groundwater, well, the change in groundwater level, it's not very fast, it's very slow. I don't have the latest data, but this data is of March 2020. I'm sure there has been, when the maps come today, you'll find that there's a change, but I don't think the change will be that much. Now, if you look very carefully here, you'll realize that we do have problems in especially in the Limpopo area up north over there. in this area. Wherever you see the reds, you can see in the northwest as well, and in certain areas in the west coast, coastal areas of the west coast over here. And of course, that area that, of course, my friend Kobus shown as when most everywhere we have higher than normal rainfall, we have lower than normal rainfall. We still also see this reflected in the groundwater level in those areas, and of course in certain areas in the Namakwa land as well. Otherwise, this is the state of the groundwater. Can we get to the next slide? Let's have a look at now the implementation of the operating rules and look at the water situation in terms of that. I'm going to share with you 4 systems. If anybody needs all the systems, we can send this out. I only chose 4, but just to illustrate the point. If we look at the Al-Nusra system in the Eastern Cape, you will see that we have, these are the dam water storage levels for the last 5 years. We have here now the current one. We have just started the new hydrological year from the beginning of October, which will end in September. You can see that this is really very low compared to even last year, which is the red, or the year before, which is 2018 and so on. Now, that means the storage here is very, very low. The average storage is around 48.6%. And in certain areas, like for example, the Kuha area is at 7%. And that is why the restrictions there is for urban water use, we restrict to 30% and irrigation on average to 80%. And in Kuha specifically, 23% urban and 60% irrigation. The next slide. This is just the same situation, but now looking at the storage in the dams. You can see that this is just if you want to look at what the situation is like today compared to 2010, compared to 1999, compared to even 1983. There was improvement with time, but then it went down. Now it's over here. This is the situation in terms of the average dam water storage in the Eastern Cape. Let's get to the next slide. Let's go to Bloemfontein area. Let's go to the Free State. Now, the Free State is not that bad, but there's a downward trend also. If you can look at this blue line over here, is going down. Again, the lines are very, very close. It seems to be very stable, but there is a little bit of a concern, and hence the domestic will be restricted to 15%. And other users will not be restricted. The next slide, please. This is the same, of course, storage in terms of the looking at the same thing, but looking at the Free State dam storage. You can see it's 70.1% in terms of the amount of water that we have. Next slide. Cape Town. The Western Cape. Cape Town has been very, very good since the last episode, since the episode that we had a couple of years ago. You remember it was almost going to day 0. That never came. Thanks God. We never reached that day 0. Now the storage is very, very good in the Western Cape. It's higher than the historical in almost every case, as you can see. So currently there is no restrictions that is envisaged for the Western Cape. Next slide. The integrated Vaal River System dam water storage, the IVRS. Here, many people ask why, when Vaal Dam is so low at 28%, we do not have restrictions. The reason is that we do have Sterkfontein, which is another storage that we can source, which is sitting at 94%. And we have Groot Dry also at 75%. So there's no need for us to have restrictions in the IVRS system. And of course, Importantly, blue moth is sitting at 80%. You'll remember that blue moth would otherwise supply the Valhats irrigation scheme and other areas over there. So if we have this situation here, then we don't need to get any water from Val, Blue Moth Dam and so on. So the system is okay, it's in balance because we operate the IVRS SA system. Next slide. This slide is just the national dam water on average, the storage on average is just the national picture. Next slide. And then of course, the national dam water storage, you can see where we are sitting now, currently at 61.4%, in better than in 2006, better than in 1995 or even in 1983. So the total, in total, really sitting at 61.4% full, capacity. It's not that bad. So let's get to the next slide, please. These are the concluding remarks. So the water availability, of course, will reduce with time due to not only climatic stress factors, but also due to non-climatic, due to how we use our water. If we use too much too soon, we will have a problem. And of course, thanks to the South African Weather Service that has predicted that we at least have a light at the end of the tunnel. There is most of the country, they will be above normal, although of course, the brother also indicated that they'll be below normal. And he also indicated that, which is very important message, when we have the La Nina, it does not necessarily mean that we will have a lot of water. That doesn't necessarily mean that. And even then in the neutral state, like we have seen the paper by Baraki and Vellum, if you are in a neutral stage, the predictions are not necessarily that good. And of course, South Africa is a water stressed because if you look at per inhabitant, the amount of water that is available to an inhabitant South African is between 500 cubes, and 1,000 per day. That is standing within that range is stress. As soon as we go below 500, we will be of course water scarce. But that doesn't mean we are not water scarce, because if you look at the people who are the most vulnerable, they are already getting very, very little, nothing even near 500, which means that in terms of accessibility, we have a lot of, in terms of access, there is a high level of scarcity in South Africa. So these folks are the folks that we need to look after as well. Although on average we are water stressed, but of course for most people who do not have access to high quality water, enough water, they are actually water scarce. And of course, the issue of diversification of water mix is very, very important. And the regular water level monitoring is also crucial. I use monitoring here because as an aquatic scientist, although all other important management tools, instruments are very, very important, but without data and information, our modelers, our researchers, our managers are just playing games. You need data, you need information to be able to manage, to be able to make sense of things. Even students who are PhD students, if you don't have data, I don't see how you can get a PhD in science, maybe in another field. You need data. Even there, you need data, of course, but another type of data. It's very, very important, very crucial. The water restrictions are informed by operation analysis of water reservoirs, and it's a necessary and essential tool to ensure sustainability of water. Efficiency in water use is necessary and essential. The next slide, I think this is the next slide, please. I just want to acknowledge and thank a word of appreciation to contributions that I got from my colleagues in the department, Dr. Bisin Mwakwa and the other colleagues, Ntobeko Tsele, Jeannie Pashkin, Tseliwe Duli, and Mr. Fanas Fori. But I also want to thank Mr. Kubas Olifir. Sorry, I called you Oliver, bro. I spelled your surname. Miniar Kubas Olifir. We're very grateful, my brother, for always sharing the seasonal climate watch with the rest of South Africa and with everybody, everywhere, putting it on the website. Thank you so much. Thanks.
Thank you very much, Chris. I would now request Deborah to share with us the meaning of the forecast to the agricultural sector. You can unmute, Deborah.
Okay, thank you very much. As already introduced, my name is Deborah Masupa from the ARC, and today I will be sharing the agrometeorological observations together with the implications of the seasonal outlook, which was just presented now, as well as the recommendations for the agricultural sector. Okay. I will start to reflect on the previous summer season, which is the 2019-2020 season. And during September of 2019, we saw a dry start to the summer rainfall season with below normal rainfall over the central interior as well as over parts of Limpopo. And during the month of October, we've also observed scorching weather followed by persistent rainfall during the early days of November, and also that continued into the early days of September. And this is the total rainfall for October to December, showing high above normal rainfall over the eastern parts of the country, and this allowed for a planting of summer crops to commence, and to some extent it resulted in improved vegetation activity over most of those areas. By April, we observed above normal rainfall over the central provinces as well as parts of Limpopo and to the far east as the Kruger National Park. However, there were some areas which received below normal rainfall, which were the larger parts of Northern Cape, the Western Cape, and also isolated parts of the Eastern Cape, including the Eastern Free State. And in some areas, grazing was insufficient for normal cattle in the Karoo area, and also for sheep densities. By the end of the season, this is just total maize production, just to give us an idea of how the production was like. This combines the outputs from both white and yellow maize. The estimate was at 15.4 million tons, which is just above 28% higher than the 10-year average. As we can see, just looking at the figure here below from 2010 to 2020, it was the second as compared to the 2017 season. Looking at the 2020 winter rainfall season, the winter rainfall region welcomed its first onset of its rainy season during the end of May, and also more intensely during the early days of June. I think you can all attest to how June month was, how cold the June month was. We had a strong cold front that made landfall on the Cape on the 9th of June, and as well as on the 11th of June, which resulted in widespread rain, strong winds, and over the winter rainfall region. And snow was observed over the mountain ranges in the southwestern to the southern parts of the country, and as far east as Lesotho. And the western to southern parts of the Northern Cape also received rainfall, where large areas received more than 25 millimeters of rain, with totals in the mountainous areas exceeding 70 millimeters, which was somewhat welcoming, considering that those areas have been hit by a multi-year drought. These cold fronts, which occurred in June, they followed another strong cold front which made landfall late in May. And it pointed out a good start to the rainy season of the winter rainfall region, much stronger than what has been the norm during the last few years, especially during the drought of the 2015 to 2017. And these strong cold fronts brought widespread frost over the interior. Similarly, the latest system also resulted in freezing temperatures over the interior. And as you can see, the minimum temperature map, showing the lowest recorded temperatures from 10 to 14 June 2020. Much of the central interior recorded temperatures below -7 degrees Celsius, with some stations recording below -10 degrees Celsius. These freezing conditions also continued into July, the month of July. So this map here shows the minimum temperatures from June to July, showing deviations from the long-term mean. And the colors in dark blue shows the minimum temperatures were below -4 degrees Celsius. Looking at the rainfall conditions, the good rains continued into July, which were critical for the dryland crop production in those areas. However, no rainfall was observed during the between the 17th to the 26th of July. Even so, the rainfall map for April to August shows near to above normal conditions over the winter rainfall region. And this is an improvement of up to 100 millimeters considering the same period last year. And one uncharacteristic feature of climate during this month was that there was a lot of rainfall occurrence over some parts of the summer rainfall region, which was not expected. Above normal rainfall occurred over the northern parts of KwaZulu-Natal, the low veld of Mpumalanga, and the high veld, and as well as parts of the Vembe district of the Limpopo province. These are the production, the crop estimates production for the winter grain crops, and these also show higher production estimates for 2020 than any other year since 2010. If you can just focus on the 2020 productions for the winter crop production. Looking at the current estimates, there has been a drought risk concerns in the Eastern Cape to other parts of the Karoo as well as the Free State. And just focusing on the Eastern Cape alone, we have seen or have observed that there were extreme drought conditions over that area during the latter months of 2019. However, welcome rains were observed during January to April this year. And this is expected. These rainfall were expected because the Eastern Cape is situated in the mid to late summer rainfall region. However, only short-term relief was experienced, and these rains were not enough to recover from the previous drought period. Mild drought conditions became apparent during May, and also these drought conditions started to intensify, implying a risk of severe widespread and impending droughts over the area. And focusing on the vegetation condition index for August, we can see the map, and the colors which are shown by the red and the brown shows below normal vegetation activity over those areas. Looking at the percentage of average green seasonal greenness for July to October, cumulative vegetation activity since winter indicates low activity over the southern parts of the country, which is shown here by the red color. And this is also an indication of poor grazing spanning from these southern parts of the country and also much of the Karoo area. And during the beginning of October, we received somewhat near normal rainfall. And also over parts of the Mpumalanga, we've seen above normal rainfalls. However, the dry conditions over the rest of the maize production areas should be alleviated. The rainy conditions that occurred during the latter days of the month, which was the latter days of October, and during the beginning of November, which is still well within the planting window. Rain during the early October had a positive impact on vegetation activity over the eastern and the northeastern parts of the country, where grazing conditions improved. This is shown by the green color on the map. However, due to lack of rain over the central interior, there is still no positive response indicating an increase in the availability of grazing. This is also underlined by extensive wildfires in the Free State during the past 2 weeks. Okay, now the implications of the seasonal outlook, as well as the recommendations for the 2020-2021 summer. Using the September seasonal forecast, we've seen that it shows that the ENSO is in a moderate La Nina state during early and mid-summer. And focusing on rainfall, given the above normal rainfall over the summer rainfall region, which we have been experiencing, soil water should not be below normal at the moment. And this combined with the predictions or the forecast for rainfall implies support for planting and early vegetative development for crops. The temperature for the forecast for minimum temperatures rather, doesn't indicate anonymously warm conditions over the summer grain production areas during the next few months, sorry. Normal to below normal maximum temperatures during this middle part of the summer is supportive of crop production, as optimal temperatures for maize production are somewhat lower than what is usually experienced over the interior. With this being said, farmers should be prepared for good summer rainfall conditions, localized flooding, possible livestock mortality, damaged infrastructure, recurrence of heat waves, outbreak of pests, disease, and wildfires. And the relatively good rains imply satisfactory crop performance over the summer rainfall region. And also rainfall could speed up regeneration of pasture yields over the area. However, it should also be noted that there may be a possible risks of localized flooding, which may wash away seeds or even damage developing crops. And there's also a possibility of poor rainfall distribution, which may result in wet and dry spells, and also the risk of insects, plant disease, and invasive weeds. With relation to planting, it is recommendable to plant within the normal planting window. Adjust date accordingly with the onset of rains. Consider various cropping strategies based on soil moisture content. Increase planting area, plant high yielding cultivars, and also plant in contours if farms are situated in mountainous areas. And also to reduce or to minimize the risk of drought or dry spells impacts on on crops, farmers can be advised to practice rainwater harvesting, to prepare for hailstorms and destructive winds. Consider cover crops to minimize evapotranspiration. Monitor constantly on the for insects, disease, weeds, and ticks on livestock. Practice rotational grazing and also keep animals in small camps with water and shade. For fires, these are the recommendations that can be given to avoid a buildup, excess of litter, and control weeds. Inspect fire breaks and rework background fire breaks as necessary. Repair erosion control measures as necessary. Control access by vehicles and people. And background fire breaks should be stabilized, and it is also advisable to keep track of extreme weather warnings issued by the South African Weather Service. Thank you.
Thank you very much, Deborah. We would now invite Joel Potai to give us a talk on progress on applications. Joel, can you hear us? In the meantime, while Joel is connecting, we can talk to the questions which were raised earlier. Chris, there's a question on why there are no restrictions in the Northern Maputoland, where groundwater levels are continuing to decline.
Thank you. Thank you for the question. I don't have the answer for that question. I'll have to interact with my colleagues who are directly involved in restrictions and to check in if indeed in that very area there are no restrictions, water restrictions. But I also want to respond to the question. Let me just take them up. I would also like to respond to Nanda's question on the strategic water source. Evidently, the impact will be reduced runoff and reduced recharge, as well as, of course, the climate change-driven high evapotranspiration by vegetation. So there will be less water because of that. The subcatchments that will be impacted negatively, of course, will be those that are within the strategic water resources, especially with respect to groundwater. I think the interventions needed from the infrastructure development perspective would be for any new infrastructure to have the flexible and the adaptable infrastructure, the green infrastructure, But for the existing ones, really, what we need to get our ducks in a row with regard is the operation and maintenance. We need to really up our operation and maintenance. The other one, I think that's it. But again, the Nanda's question on Mahala Dam, of course, you are very right. In fact, the current level in Katse Dam is no longer 39, it's 32.3%. And well, Mahala now has improved only to 9%. But you are right, this is very much concerning. But as far as I don't know the predictions in terms of the rainfall over Lesotho, I think our source colleagues can assist. But the risk to transfers is also very high. We will remember that we are transferring 23% from Lesotho to South Africa. However, there was a time when for a very long time, we were not transferring any water during the repairs to the transfer scheme. And we were relying on Sterkfontein and other supplementary sources to supplement our water to the IVRS. I think that's all I can say. Thank you.
Thank you very much. Joel, are you connected?
Yes, thanks a lot. Sorry again for these technical problems, but I'm connected now.
Thank you. You can proceed.
Okay.
And I'll come back to you, Nanda. I'll come back to you on offline.
Sorry, I'm just trying to connect. Give me a minute.
In the meantime, you can continue to post the questions in the chat room.
Okay, I'm trying to trace my, I think I've got several files here. Let me check them out.
Would you like Tobile to share your presentation, Joel?
Yeah, maybe, but I wanted to actually control them myself. Yeah, okay. Yes, but she, because I'm taking a little bit long, she can share. Then maybe I'll proceed with that. Yeah, she can share. Brilliant.
Tobile?
Is this the right one? Am I sharing the right one?
Yeah, correct. Yes.
Okay. Sorry. So I'm just making a full screen.
Yeah.
There you go.
So will you give me permission to control the movement, right?
I'm not sure how to do that right now. I think I'll have to control it for you.
Request control. Yeah, I've requested control.
Okay, there you go.
All right, great, thanks. So colleagues, thanks a lot for the opportunity, and I'm happy to give a presentation on advances or progress in application development with regards to weather and climate, specifically for developing societal applications. And the next slide, oh, looks like there's a problem still. Topila, you can move to the next one, I think. Yeah, good. So the outline is basically just to give some context, background, some insights in the weather and climate application research, and potential application areas and summary. The idea here is to present to the team our new thinking of applications research framework specifically for drought monitoring and prediction. So as part of my introduction, I would like to start with saying that the world is undergone a number of changes, and these changes are largely driven by climate change processes. And this climate change variability impacts actually they are akin to rattling anyone's skin. So if you look around, for example, South Africa is facing extreme risks ranging from climate to corruption. And that is very important to allude to that. So extreme weather phenomena, political risks, corporate scandals top the risk of the risks that South Africa faces. And if you intertwine all these problems together, we are confronted with a mammoth task, and society will be faced with a lot of challenges, or is facing and will be faced with a lot of challenges in the future. If you look at the global risk landscape from the World Economic Forum, you realize that the extreme weather events, natural disasters, and a society failure to adapt, to take action on climate change in advance tops the risk of impact and variability. So the weather and climate risks will always be omnipresent. For example, just a couple of days ago, in the headlines, South Africa is drying up and it's only going to get worse. And that is why, as a reaction, the ministers, for example, the Minister of Finance has allocated some budget, 50 million to support drought-hit farmers. The Department of Water and Sanitation has set aside an extra 300 million for emergency funds. So all these reactions is a realization or manifestation that actually we're faced with weather and climate risks, and we all need to confront these risks together. And to confront these risks, we need some factory of knowledge. That is the knowledge generation. That involves past events, or taking stock of past events, present events, and future projections. We know that we are confronted with droughts, flooding, and many other heat waves that the last speakers just mentioned. But it's important also to look at the past, the present, in order to prepare for the future. So with regards to applications research, I think it's important to allude to the fact that translating research to operations is akin to navigating through what we call the valley of death. We know that a research to operations requires structures, require financials, and skills resources. It's amazing that actually all the resources for both research and operations exist, but the only missing link is that transformation, that is the transforming of research to operational products and services. So, but to do this requires a complete change of our mindset. And this is simply because we have to think collectively about the complex problems through a process of framing and reframing. So we need to define our research so that it encompasses an aspect of interdisciplinary and moving or overcoming what we normally confront ourselves with, that is the ivory tower syndrome. So we need to move across boundaries, both horizontally, that is across disciplines, and vertically, that is across experts, policymakers, and the public. But it's also important to understand the interface between the scholar and practitioner. And because of this, then there's need for scholars to generate new knowledge that is useful to practitioners. And this is only possible if we take cognizance of the inherent challenges that are characterized. For example, subjectivity, the varied theories, the models, and most importantly, the epistemology framing or inclination. So this is akin to looking at the problem that we face in a very complex way. And we need to frame our research in terms of solving nonlinear problems. And that means that we need to seek solutions for nonlinear problems, which are premised on, for example, the ontology, the methodology itself, and also the axiology. And that is basically, in simple terms, it means that we need to understand the user needs and redefine our way of disseminating the knowledge that we generate. Now, at the research processes at source is akin to what we call the knowledge production and delivery through a number of subcomponents from observations, modeling, forecasting, and service production. So the service production delivery is actually embedded within a larger process of creating value. And specifically for the purposes of this panel, I would like to zoom into what we call hydrometeorology research. And basically, the focus areas that are currently operational include, but not limited to, multi-hazard warning, hydrological modeling, characterizing extreme hydrological events, and weather and climate variability. There's some point that is hidden here, what we call socio-hydrology. So those are aspects that we are looking at. Just an example of what the team produces. So just to supplement the water and sanitation department, we're also focused on understanding or developing tools for stream flow forecasting. As you can see here, the guys are able to forecast and demonstrate that the stream flow values within 1 month, 2 months, 3 months with different time scales. So this basically the tools that are being developed. But most importantly, and which is very important for this presentation, is about drought monitoring. So the drought monitoring is conceptualized via a number of variant parameterizations that includes what we characterize here in terms of severity, duration, frequency, and also different other categorizations. For example, mild, severe, extreme conditions. But recently, we are able to demonstrate that we don't just give a stationary account of drought conditions, but rather we developed a tool that demonstrates that we can track the propagation of drought, the evolution of drought from meteorological drought, moving to agricultural drought, to hydrological drought, and into social hydrological drought. So SOURCE is able to produce that, is able to give out that tool. And this has, of course, peer-reviewed and published. And recently, we have then developed additional tools to actually determine or quantitatively estimate the onset and cessation of this drought. So, and this is through empirically determining specific functions, that is distribution functions that are able to determine that. Most of these are actually what we call the sigmoid functions. And we test various varied tools of sigmoid functions that are ideal for South Africa. And apart from just mentioning the drought impacts, we have a little bit expanded the drought risk, the drought estimators into what we call the drought risk assessment. And this is through a copula paradigm. A copula is basically a mathematical function that actually couples or joins 2 or more time-dependent and actually could also include spatial-dependent functions. And we have a number of them, and we've tested all these tools, all these functions. For example, what I'm listing here: Gaussian, Clayton, Frank, the Gampel, Joe, and many others. All these have been tested and analyzed for specific cases in South Africa. And the results I'm going to present here This is just a mathematical equation that talks about risk estimation or assessment based on a framework, the Copula framework, and that tells us about the return periods of these droughts. So don't worry about the mathematics, but maybe the most important part is the next section. So we've tested this drought risk assessment, and I was happy to note that the ARC has presented something about the Eastern Cape, and I could draw the colleagues to a paper that we published on the same. So, and here we determined the best probability distributions that models the marginal drought duration severity based on SPI of different timescales, and we are able to determine accurately with a statistical significance of 5% what is the best probability distribution that characterizes drought duration and drought severity. And the numbers here just give you some statistical values that talks to the Kendall value. But most importantly, in analyzing the Eastern Cape specifically, we are able to determine the various return periods, that is the 2-year return period, a 5-year return period, 10-year return period, 20 and 100 return period, drought return periods. And from this analysis of return periods, we have come up with a number of key important conclusions. For example, we've determined that the Eastern Cape has experienced drought episodes. And if you refer to this article, you will see what the definition of a drought episode is. 5 to 8 drought episodes with an average of 60 to 80% likelihood of occurrence, that is in the last 5 decades. So the Eastern Cape, over the last 5 decades, it has experienced 5 to 8 drought episodes that have a 60 to 80% likelihood of occurrence. Now, knowing this fact will really help you, understand what has happened in the past and what is likely to happen in the future. Actually, the team has analyzed the future episodes, and the results are already being analyzed. We are validating the results, which we'll present shortly in future engagements. So the Eastern Cape province is more likely to experience maximum drought conditions that last more than 12 months, while those that exist 24 months have a 33% likelihood of occurrence. And for the purposes of future analysis, we have determined that 5 copula families, we have a host of 27 copula families. So 5 copula families from specifically Archimedean and elliptical copulas are duly suited to represent the multivariate characteristics of drought conditions in the study area. So these copula families are therefore candidates for ideal drought risk quantification in the Eastern Cape. So if we move this to, for example, Limpopo, we might find different copula families. So that is still work that we're working on. So in terms of the return periods, we have 2 concepts, what we call the conjunctive or cooperative multivariate drought risk probability index. And the results show that the area has a northwest to southeast gradient with Buffalo City, OR Tambo, and Alfred Zoe regions, determined to have higher and lower risks. So colleagues, with this, a new framework, I would like to conclude with the following. Firstly, there are a number of, as a community of practice, the use-inspired collaborative research is advocated for. But to do this, there are a number of open questions. For example, how can members of the weather and climate scholarly community position themselves in what we call a pasture quadrant? Now, the pasture quadrant is a quadrant that is an interface between pure applied research and pure practical research. So it's an interface between pure applied research and application research. And this calls for the association between the scholars and practitioners. So we're questioning whether are we able to enact that role of being both scholar and practitioners, or how do the two communities work together? We form collaborations, MOUs, which ought to be nuanced, a carefully nuanced balance between the logic of practice and that of embracing logic of transdisciplinary research. So most importantly, then the next question is, how do we ensure that the solutions that are sought are premised on both analytical and empirical insights? And with these, colleagues, I would like to end the quote that let us be ready to confront the truth. Science is objective, is rational, is evidence-based, and is founded on reason. Thanks a lot.
Thank you very much, Joel. I would now like to invite Franco to come to talk about the projections of future seasonality of COVID-19 in South Africa. Franco?
Hey, Bernard, can you hear me?
Yeah, I can hear you.
I'm just having a small technical glitch. I'll be online. I'll be able to share my screen in 30 seconds, I think.
Okay. From the speakers, any who want to respond to some of the questions posted in the chat?
Brilliant. I'm getting a message here that I can't share my screen because another screen is still shared. I guess this one, I guess it's Joel's, which must first be removed.
So will you please unshare the screen? You can go ahead, Franco.
Thanks. Good morning, everybody. It's still 2 minutes before noon. I'll switch the video on swiftly. You can see I'm still in lockdown mode. I can see Brilliant is smiling. Let me switch our video and share my screen. Brilliant, many thanks for the invitation. Colleagues, Brilliant initially asked me to speak about climate change and infectious diseases in our region, probably because he and myself have been part of a project focused on malaria prediction in Southern Africa for many years. But I pointed out to him more recently that I have in fact got involved quite closely in South Africa's COVID-19 modeling effort, specifically from a seasonality perspective. And we then thought it may be a good idea to also share with this forum some of these latest insights into COVID-19 in South Africa. And specifically also about the potential role that weather and climate have played and may play in its spread in South Africa. So let me jump into this talk. Let's see. Just trying to move the slide on here. Yeah, okay, there we are. So let me first point that in South Africa, we do now have a bit of formal structure in terms of studying the environmental impacts of climate, of our environmental impacts in general, primarily climate, on COVID-19 transmission. So specifically, quite early on in the process, it was back in April this year, the COVID-19 Environmental Reference Group was formed under the auspices of DSI. And very, very swiftly, this loosely formed consortium got going. And in the end, I thought quite efficiently supported the country's larger modeling effort. So the main questions to ask here is whether weather patterns and seasonality impact on COVID-19 infection rates. And then, of course, also whether we can use all the experience we have, for example, in the community that's meeting here today, or our experience in working with scenarios, for example, in the climate change context. Can that experience we have perhaps help communication, the science around COVID-19 modeling and predictions? Now, that was really important around about May and maybe April, May this year, when we were amidst in the pandemic, and it was becoming very important to communicate to the public the results from the modeling, but also the uncertainties associated with the modeling. And then over the last few months, the COVID-19 climate modeling effort in the country did produce several outputs. I've listed several of these here, but let me just point out that there is a review paper published recently, Smith et al., you'll be able to Google it, that discusses potential seasonality impacts in the Southern Hemisphere. And then maybe from a practical point of view, the most important thing this consortium did was to provide spatial data sets of daily climate to each of the municipalities in South Africa for the purpose of this being applied in the National Institute for Communicable Diseases spatial COVID-19 model. And the scenarios that this model generated as part of South Africa's larger modeling consortium was then informed by these climatic anomalies. So that was part of the scenarios that were generated. So then, of course, the academic effort also was being pushed all the time. And today I'm going to share with you some of the findings that I do think are quite important for our country moving forward. So I'm going to speak specifically about seasonality. I'm going to speak about the possibility of a second wave developing in South Africa. And I'm going to say, to also give you an idea that is reasonably new, but that I think, and several colleagues think, is a very big part of what happened in South Africa in terms of COVID. So let me start by this slide. It turns out that there is a framework available internationally in terms of how to study the impacts of climate and seasonality on a great variety of infectious diseases. So in the theoretical work, one usually assumes that there is some seasonal type profile, typically a cosine function that is used. And it typically describes how the effects of climate reduce infection rates from an optimal state where conditions are perfect for the disease to spread towards another state where conditions are less favorable. Now, for COVID-19, the basic theory is that when we reach conditions that are maximally dry and cold, it favors the infection. It favors infection rates most strongly. So the basic idea is the less moisture there is in the air, the longer the virus can float around in the air and infect people. So the empirical findings are that the greater the content of water vapor, the quicker, the faster the virus gets gravitated to the surface of the earth by water droplets. And it is then also, there's also some evidence that that the coronaviruses that we know better, at least, and also the flu virus, is less stable and it lasts longer in the air in a form where it can infect people if temperatures are cooler. So there is evidence to think that these viruses become less stable in the air and on surfaces at higher temperatures. Now, it turns out that in the early days of COVID-19, there was a tremendous research effort internationally, and several researchers tried to quantify exactly how the effect of climate modifies the infection rate. Now, what is now known as the climate correction factor. And the climate correction factor is a number that ranges in size between 0 and 1. And it effectively functions to describe how warmer and more humid conditions reduce the infection rate compared to its optimal value that exists under the optimally dry and cold conditions. So effectively, the infection rate decreases linearly with temperature. And then there are also effects when the absolute humidity reaches values of more than 9 grams per cubic meter. There are other formulations out there, but this is the one that we've been using in most of our research. Now, if one calculates this climate correction factor, if one applies this formula to the temperature and humidity profile of Johannesburg, for example, one finds this type of pattern. So not surprisingly, you can see that in June and July, this formula dictates that conditions were perfect, optimal for COVID-19 infection and transmissibility in the high-veld regions of South Africa. And then by the time that we reach midsummer conditions, you can see that infection rates are about 30% lower because of climatic effects under this assumption. So if we apply this formula countrywide, one can make maps and see how the infection rate was influenced or will be influenced by climate in South Africa. The darker red, the more optimal are climatic conditions for COVID-19 transmission. And you can see that by June, we reach optimal conditions, but by March and earlier into the summer, infection rates are reduced by a factor, as I've mentioned, of about 30 to 40%, depending on where we are in the country. So in the model simulations I'll show soon, we use some of these effects, these runs, or these maps, and you can see that really wintertime was really perfect under these assumptions for COVID to spread in South Africa. Now, of course, the infection rate under these assumptions will be substantially reduced already by the warmer conditions we've experienced in October. And of course, that will be even more suppressing deep into summer. One can also generate global maps of the potential of seasonal impacts on COVID-19. So if I apply that climate correction factor globally, using the crude data set of temperature and humidity, one finds this type of map. So the darker red, the stronger will be the seasonality in COVID-19 infections. And of course, here in the subtropical parts of the Southern Hemisphere, we are looking at very strong seasonality. In the tropics, seasonality under the climate correction factor formula is, of course, significantly less. And the same is true in the higher latitudes. So if we want to go and look for evidence that there is indeed an observable impact of seasonality or climate on COVID-19, it's not a good idea to go and check in Sweden, for example, or in Iceland, as some people suggested in the early days of COVID-19. it's also not really a good idea to go and look for evidence of seasonality in the tropics. And indeed, also for influenza, there's not a pronounced season in the tropics. So South Africa is a country that potentially can display a seasonal cycle in COVID-19 infections as we move into the future, past the pandemic size. The pandemic stage of the disease. So what happened in the end in South Africa? Well, if you look at this slide, you can see that the pandemic really moved through South Africa. As we all know, within 2 months after we relaxed our state of lockdown. So on this graphic for the Western Cape, you can see that infections peaked more or less at the end of June. And of course, unfortunately, of course, it was also true that the mortality rate in the country followed suit. And more or less by early September, I think there were about 6,000 deaths already recorded in the Western Cape. Now, in these graphs, I'm also distinguishing between the COVID-19 reported deaths and the so-called excess deaths that are calculated by our Medical Research Council. Now, in Gauteng province, the peak infection occurred more or less in mid-July, just about 2 weeks later than in the Western Cape. For South Africa as a whole, we peaked in terms of the national numbers more or less at the end of July. Now, I think in early October, we had about just over 40,000 excess deaths that have been reported, that have been calculated for South Africa. So the main point I would like to make today is that I do not think, well, there are 2 points. The first is I do not think that seasonality played an important role in the South African case, simply because of the fact that we started to relax our lockdown firstly on the 30th of April. That was the first major relaxation in our control measures. About 1/3 of people returned to their works on the 30th of April, or to their jobs on the 30th of April. And then about a month later, there were further relaxations in the restrictions. As a consequence, the disease peaked in our country mid-winter. There was effectively zero time for seasonality to have any significant impact on COVID-19 infection rates in South Africa. So that's my view on this specific aspect of COVID-19. So what about the future, and what do we know about what has happened here in South Africa? Well, for this we use modeling, of course. So at the Global Change Institute here at WITS, we use a susceptible, infected, recovered, dead model for the predictions. There are the equations. I won't say too much about it. I think many of us now have an idea about how these models work. But effectively, you divide the population into a susceptible category, an infected category, a recovered category, and a dead category, to phrase it that harshly. And from this rather simple set of equations, the dynamics of how a disease spreads through a simulation can be surprisingly realistically described. And now I'd like to share with you some of the findings for our country that I think is useful in terms of understanding the risk of a second wave occurring. This is the first graph. Now, on the x-axis here, we have the infection rate, effectively, but it's here represented by the so-called R0 value, the basic reproduction number of the disease. Effectively, this means Let's say we are at the beginning of the disease and the entire population is susceptible, and we have one infected person. How many people will that infected person infect in turn? So you can see, maybe you've also seen in the media in recent years, the R0 value for South Africa is thought to be somewhere between 2 and 4. So that means every person on the average is supposed to infect about 2 to 4 others at this early stages of the disease when everybody is susceptible. And here on the y-axis, we have the so-called infection fatality rate. So that effectively means what percentage of people can we expect to die from the pool of people that are infected. Now, this result here is then specifically simulated deaths in South Africa's Western Cape, more or less by early October this year. It's a theoretical simulation that just ran 6 months into the future. And the red line is important. The red shades that you can see here denote between 6,000 and 7,000 deaths. So right now, by early November, I think we are more or less at something like just above 6,700 deaths in the Western Cape. And colleagues, this is a surprising finding. We've lost many South Africans, more than 40,000 it's estimated across the country, but it is still far less than initially modeled and predicted. Now, how does this work? Internationally, there's evidence that the infection fatality rate ranges something between 0.3% and about 1.3%. That's the upper estimate. The mid estimate is about 0.68%. So 0.68% of people that get COVID-19 die in the end. Now, you can see that if we are looking at basic reproduction numbers, so the infection rate as observed across the world, basic reproduction numbers, something between 2 and 4. You can see that for such high infection fatality rates, well, this is actually just a global mean, right? 0.68. There should have been in the Western Cape alone more than 30,000 deaths. And if you do that calculation for South Africa, you'll find that there should have been in South Africa more than 200,000 COVID-19 induced deaths. It's because of this tremendous threat that the government, of course, installed that extremely strict lockdown at the beginning, because that is what was an absolute tragedy that was awaiting South Africa. Now, in the end, this didn't happen, despite the fact that because of economic reasons, we had to significantly relax the lockdown, as we all know. So what on earth has happened in South Africa? I've already explained that it was most likely had nothing to do with climate. In the interest of time, I'm going to move, I won't talk too much about the timing of the peak infection, except I can say that you can see that here we are looking at the timing to the peak infection from onset of the disease in intervals of days. And you can see that within 4 months, for these high infection rates, the disease has been simulated to move right through our population. And that indeed is what has happened in the end. So what is our theory of what has happened in South Africa? And then I'm going to get to talking about second waves, and I'll conclude. To make a very long story short, and after several months of running many simulations, considering many different effects, initially also seasonality, I think an insight has now emerged that there is something quite special that happened in South Africa. And there's some evidence that this effect is in fact working also in other parts of the world. Maybe we will not turn out to be that special. So what is this factor? Well, in these graphs, I'm plotting on the x-axis the initial susceptibility of the population. You see the previous graphic I've shown, and all the initial modeling in South Africa was based on the assumption that we were all susceptible to the disease at its onset. But there are now a few very good reasons to think that maybe this was not the case. So here the modeling explores different possibilities where only 90% of the population was susceptible, only 80%, only 70%. So 70% people susceptible at the time of onset of COVID-19 in South Africa means 30% had a form of what is known as cross-immunity. So 30% people were immune to COVID-19 before ever encountering COVID-19. There are two main theories why that may be the case. The first is South Africa's BCG vaccination program, so our tuberculosis vaccination program. And the second idea is out there that because of the fact that in our informal settlements, at least, South Africans are quite often exposed to the commonly circulating coronaviruses, the viruses that give the common cold, that frequent exposure gave some cross-immunity also to COVID-19. Now, if we make this assumption of cross-immunity existing in the population, you can see that we can simulate 6,000 to 7,000 deaths for these realistic values of R0. So typically for, let's say, cross-immunity of 30%, you need an R0 of about 2.4 to explain what happened in South Africa. That is entirely realistic. And this is for this result is for an infection fatality rate of 0.31%. And there are also plausible ranges that can occur for R0 and a higher infection fatality rate that can explain what has happened in South Africa. So I need to start concluding. Now I'd like to conclude by talking about the possibility of a second wave in South Africa. So I'll just have this one more slide and then I'll conclude. And I'm just going to focus on this left-hand side graphic. On the top side, we simply have details, and the right-hand side and the bottom is simply an alternative result for a different infection fatality rate. What you can see here at the bottom left graphic, this is what I personally think has happened in South Africa based on all the evidence considered. So yeah, we are looking here at infections scaled by the total population in the Western Cape specifically. And in this case, we've used a model in so-called inverse form. So from the excess deaths, we've run the model in inverse mode, and we've obtained the infections that resulted in the deaths. And then on the 2nd of September, we released the model. And we considered several cases. The first is the entire population is susceptible. And then you can see as the colors go towards the warmer colors, a fewer and fewer fraction of the population being initially susceptible. So 60% susceptibility, as I've mentioned, means 40% cross-immunity. And what you can see here is that if the population was fully susceptible, then by now, we should have seen a tremendous second wave of infections developing after lockdown. Okay, that wave should have been fully formed by early November. It hasn't happened. Under the assumption of cross-immunity existing in the population, you can see 20% cross-immunity gives us this yellow line, the so-called slow burn. I personally think that is exactly what we are currently observing in South Africa. And as the cross-immunity state increases, the infection over time is even less in South Africa. So if the cross-immunity assumption is correct, there is, we can say that a second wave of infections is not likely. in the remaining part of 2020, which will of course be wonderful news for the country. Okay, I think I should conclude. I think I've provided evidence in this talk, modeling evidence at least, that if our population was fully susceptible, things would have been much, much worse in South Africa in terms of the number of people that died, in terms of the pressure on our health system. On the other hand, if we do make the assumption of 30 to 40% cross immunity, we can explain almost everything about our infection curve, when the peak occurred, the size of the peak, the number of people that died, and the initial results from serological testing. I didn't have time to go into this in too much detail. But more or less by early August, there was evidence that about 40% of people were infected in the Western Cape. Now, that cannot be explained for the case where everybody is susceptible. But if there was another 40% that had cross immunity, then of course we can understand why the Western Cape peak occurred mid-June and why the same behavior followed later on in the other South African provinces. So very last point, what about seasonality? The big question right now is whether we are going to lose our immunity to COVID-19. That is a big unknown right now internationally. If people are going to lose their immunity in more or less 12 months after being infected, I'm using that number because that's more or less the time that it takes us to lose our immunity to the common cold, to that virus. If COVID-19 is going to behave in a similar way, we unfortunately face a major risk of a second wave somewhere between March and July next year, the modeling tells us. And that wave, that second wave, unfortunately, may well be influenced by the colder and drier conditions of winter in the absence of a COVID-19 vaccine or in the absence of renewed non-pharmaceutical control measures. That is a new lockdown. So that is the thing that I think we must be absolutely aware of, and that I'm sure our NICD and our Medical Research Council are closely monitoring. Very last thought, colleagues. Although the Global Change Institute modeling does not indicate a likelihood of a second wave forming this year, remember, as always, as we've discussed this morning for our climate models as well, these remain only models and predictions. And we know there are still COVID-19 infections around in South Africa. So one can still get infected even during the slow burnout of the disease. So let us all remain as careful as we can to not get infected in what is hopefully these last stages of the disease in 2020 in South Africa.
Thank you very much, Francois.
Sure, brilliant. I'll stop sharing.
Okay. By show of hands, we can take a few questions before we wrap up the dialogue. Thank you. If not, I'll now invite Shafiq to provide us with the reflection of the discussions of today's dialogue.
Thanks, brilliant, and hello everyone. Yeah, extremely interesting discussions today. Thank you for all the joined in to some of my ideas. We've all heard the presentations. We've all seen some of the questions and some of the responses. And I must say it's heartening to see the partnership and collaboration across the different institutions with the common goal to provide some sort of advisory. But some of my reflections are, and I think Francois illustrated this because I wrote this probably before the thing started, is how do we bring in other sectors or other stakeholders into this discussion? And of course, the health sector is now represented through the COVID work that Francois and others have been doing, and then trying to link it to climate, or try and look at the impact of climate and weather on the infection rates and so on. But who are the others? For example, I think Desigan mentioned the economics of climate and weather. Can we bring in those sectors into this discussion and say, okay, but these are the challenges and these are the opportunities for the future, and whatever that temporal scale might be, and then start working that out, because I think that discussion is missing. The other participants spoke around agriculture. Chris spoke about water security, etc. And all of these drive an economy. And often it feels to me, sitting at the Water Research Commission, that we often speak to ourselves. And I haven't interrogated the participants list, but how many of the other sectors are represented there? And then also speak to something else that I want to reflect on is how we communicate around some of these products, because it's excellent. It's world class in my view. And how do we better use what we are saying here today and through the advisories to and I'm just thinking, for example, on the East Coast, how do we speak to the northern KwaZulu-Natal guys and say, okay, this is what we see in the predictions, or are we expecting them to read about this in a broader national advisory? Are we putting boots on the ground to go and speak to those municipalities that are now probably in the second season of a drought, and it does not look good going into the future as well? So and how can we better use things like infographics and social media, etc., to drive these messages? And then it's not just a government type of responsibility to take note of these and that then translate into decisions and policies at the local level. And speaking of the local level, I think the other one, and I think it was Nanda that asked the question, how do we get to a more granular situation? How do we scale these things down? Because if we speak about water security, it's fine to speak at a water management area or a provincial level, but in those areas, in those 70% or 50% provincial numbers, there are dams that are at 2%, and that then affects the water security at the local level. And how do we translate some of these advisories that it's likely going to rain or not going to rain, and how do the local authorities need to organize themselves to capture more of the rain? How do they prepare for these things? And of course, the opposite is also true, is that what we are seeing is that we're getting more rain. So we said there will be above normal rainfall in a lot of areas. But I made a comment the other day, I think it was to Desigan. If you drive around just in Pretoria, I have not seen anyone servicing the stormwater systems. No drains have been opened to check what's in there and declog them and clean them, etc. But certainly, and we've seen it already in certain places, when we have these high intensity, high rainfall periods, it just overwhelms the system. So again, in terms of the advisory, who needs to hear this? It says, okay, please maintain your stormwater systems, and it will likely not be able to handle if it is dirty and clogged, etc. Some of these systems, and of course that dirt and plastics and all eventually will find its way to the river system. So you kind of have a double positive benefit. The other issue is around how do we speak And I think it was Kobus that spoke around what those maps mean, what above normal means for the summer rainfall versus the winter rainfall period, which then in turn translate to how we inform decision makers and others around issues of uncertainty and understanding probability, and then all these things. But I think for me, one of and maybe just to wrap up is how do we get to the translational aspects of what we are doing? How does this translate to a better economy? How does it translate to a better environment, etc.? As opposed just to say, this is what we are seeing, and should that be part of this advisory panel's mandate to say, okay, but let's look wider to in terms of predictions, agriculture, etc., into a more broader aspect that affects society and the economy, etc. So I think I'll stop there, and then I'll hand back to Brilliant.
Thank you very much, Shafiq, and thank you also to our speakers, our panelists, and more importantly, our audience, our important partners and stakeholders. I'll now request Stanley to give closing remarks and officially close the event.
I guess my time to speak now, isn't it?
Yes.
Okay, sorry, my connection is like I lost it a little bit. But anyway, let me come in. Thank you very much, Brilliant. I think I should also start by congratulating the panel as well for putting together such a work relating to our climate. I mean, one can also call it climate watch and advisory for South Africa water sector and sanitation. I think this is very good. I just want also to reiterate what our CEO, Desgen, actually was mentioned. So surprisingly, surely this is becoming very much useful. And than maybe when we started, or the thoughts that we had when we started. But thanks, Des, for the vision, and also you, Brilliant, actually, for the vision that actually you two have put together. But I think some of the things that I just want to maybe reiterate again, because most of the speakers talked about, it is the issue of using this platform or using these products for decision making. And I think we should continue to look for them, for the customers, or for the people who can really use this and make impactful changes in our systems, in our departments, in our different sectors. Maybe we shouldn't be satisfied with the people that we are already talking to. We should seek more people that we can really push this and these products and even engage, so that we can get the full benefit of the great work that has been done and that is still being done. So looking at the whole presentation, surely one can see the connections from agriculture in terms of, if we are going to have more rain, how should we actually be prepared, you know, in the next 3 months or even beyond these 3 months. I mean, and surely there's so much that we can think about, the diseases, the pests and so on that are associated with that. But again, also in terms of the yields that our land can potentially provide or give. So those kind of thoughts actually are very good, and we need actually to advise both the small scale farmers or the subsistence farmers and also the commercial farmers accordingly. And also looking at the investment part, when we look at this climate advice, this can also touch on it, like our infrastructure. How do we deal with that? And also Shafiq talked about how do we take care of our infrastructure when we know that we're going to have good rains, above average rainfalls. And even when we've got drought, how do we deal with that? And the DWS by Chris Museko also talked about the issues of groundwater. So if we're going to have more water, or more or above average rainfall, it means even our stormwater will increase, even our rivers will overflow. So how do we deal with that? How do we think about recharging our aquifers as well? How do we ensure that we take off our dams? The DAWRC at that time we have had a meeting or had a webinar about the integrity of our dams. So one has to think about that. So I'm happy. That's one thing. This work or the products that are coming from these initiatives are really useful, and we need to actually ensure that we use it to our full benefit as South Africans and even our neighbors as well, because they will really empower us in terms of economic development and even to protect lives. So that people who live in Janskei, for example, along the Janskei River, for example, some are living really on the banks of that river, and when there is actually flooding, we lose life. And some of our bridges are also very low. So how do we ensure that we put some alerts, or we work with municipalities to be watchful as far as that is concerned? But all in all, I think this is one of the greatest initiatives in South Africa, which shows that together, when we work as science organizations, also with civil society, we can be able to achieve so much and come up with useful products from research, and research which takes us to development, from development taking us to changing people's lives. Again, congratulations to the team, and you, program director, as the leader from us in the DAWRC. Thank you very much.
Thank you very much, and let us enjoy the rest of the day. Thank you.
Thank you.
Thank you. Bye.